There is another common way of expressing potential energy of a capacitor. We just saw that U can be written as 1/2 Q squared over C, but we can also write it like this. We can replace the Q by CV, so we can do that. And then this can be simplified as 1/2 CV squared. So this is an important formula to also know how to work with. It turns out there are two ways to think about potential energy. What we just discussed was that potential energy is a result of the work that I do to separate the charges on the capacitor plates. But another way of thinking about potential energy is that there's energy stored in the electric field itself. And the way you can see this is go back to this formula that we just derived, U equals 1/2 CV squared. And recall that C, it just depends on the geometry of the capacitor system. So we developed a formula from before that looked like this. So to recall, the capacitor plates have a certain cross-sectional area A, and then they have a separation distance D. And then you're putting a plus Q here and a minus Q on the bottom plate, and the electric field heads downwards like this. So going back to this formula, 1/2 CV squared, you can write it as 1/2 times by C times by V squared. Now, V squared can be rewritten. So for a capacitor system, there is a potential difference between the two plates, which we have written as delta V, which is also written as V, and that this quantity is equal to the electric field times the distance between the plates. So you can go to this line and replace the V by ED. So let's do that. And you get the following. So now you can simplify and you will get 1/2 epsilon naught. The A survives, and then 1 factor of D, and then you have E squared. So this is saying that the A and D only depend on the geometry of the capacitor system. These are just constants, and so the potential energy is only determined by the electric field between the capacitor plates. Sometimes it's more easy to think about energy density. Density can mean different things. Energy density means the energy in a unit volume. And it's easy to do because when you look at the formula for potential energy up here, you see that AD is the volume of the capacitor plate. So therefore, what you can do is take U and divide it by the volume, and then that equals 1/2 epsilon naught E squared. So sometimes this quantity is more convenient for understanding the science of the problem.